Hey, what's up, guys? Welcome back. I think episode, what, 60 maybe? 59? I don't even know yet. 60. Episode 60 today. Oh my gosh. Well, yeah, we're gonna do a few problems today. Oh man, it's cold in here. Jeez. Maybe I might put on a hoodie or something. But yeah, it's cold. Do a few problems. So let's take a look at our Pokemon of the day. We got a Poliwag. Let's check out the sound. Ditter. 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 That's totally off, but ditter. I don't know how to do it. Like, it sounds a little too tough to mimic. Anyway, so I was looking at the problem of the day just before I turn this on. Just take a look at it. Man, it's cold. We're going to attempt to do this one. So from what I've read here, we just pretty much need to loop through this array and check if nums I is equal to nums I plus 1, then multiply nums I by 2 and set nums I plus 1 as 0. And after running all operations, you shift all the zeros to the end of the array. So let's go ahead and do that. So we do for I times length nums. We check, well, if nums I is equal to nums I plus 1, I plus 1, we set, what do we do? Nums I times 2 times 2 and then we set nums I plus 1 is equal to 0. Let's print our nums. Check it out. God, it's cold. Okay, well, for some reason we didn't times here, so why not? How we move all the zeros to the end of the array? Well, what can we do? We can. If we see a 0, we can. Maybe we can make like a right pointer or something. Length of nums. We do, well, for num in nums. We can do if num is equal to 0, then temp is equal to num. We can do temp is equal to nums, right? Then num's num is equal to 0, then we can move num's num is equal to num's right, then num's right is equal to 0. And then we move right minus or equal to 1. Turn knobs. Let's see. Output. Oh shit, I already did this one? No way. May 22, 2024. Huh. Ugh. Hmm. 12001. And I is equal to I plus 1. Let's check why are we printing here. Print nums. I think what's happening here is that, like, we're kind of looping here, and it's, look, because I think we do for nums, if nums is equal to 0, right, which it is, we set nums num, this one, equal to nums right. So this is 1 now, and then nums right is equal to 0. And then we flip here and we go to 0, or if it's equal to 0, we flip nums num is equal to nums right. Nums num, which is here, which is equal to nums right, which is here, and it flips it back. So I think that's what it's doing. We're like flipping it back. So somehow we need to check, well, as long as right and right is greater than num, then we swap. Okay, well, that worked. This one now, what's the issue here? We got 1, 0, 2. I don't know, there's some other edge case here, like... what are we doing wrong here? I don't think we're looping through this properly, so we need to... We take each number, we put it to the front. Yeah, interesting problem. You know, I think we can just, well, we can also just, I know we can solve it by creating a res array here, right? And we have I is equal to I plus 1, nums I is equal to nums I times 2, nums I plus 1 is equal to 0. And we can do for num and range of length nums. If nums num does not equal 0, res dot append nums num right? And then we just add on zeros. And then we make res 0 times the size of length nums, right? We loop, does not equal to 0. We make res, let's just make like j is equal to 0. I in range length num, num in range length nums. If nums does not equal 0, we make res j equal to hang on, someone's calling me. Nums does not equal 0, res j is equal to nums num. Then we return res. Or what? Oh, we need to increase j. J plus or equal to 1. Alright, there we go. Let's get rid of this. Let's get rid of this print though. Submit it. Yeah, I would have thought there's a faster way to do it. Yeah, interesting. All right, we'll be back. My friend just called me. We'll call you back. I mean, we'll be back in this video in a second. All right, we're back. Had a little bit of stuff to do. I gotta leave in like an hour though. Going up to Chicago, so I'm gonna do one more problem. Process this video, and I will see you guys on probably Monday. So let's take a look at another problem. That was a little bit easy of a problem. Let's do like, we'll take a look at a binary search tree problem. Take a look at deepest leaves and sum. Can the root binary tree return the sum of the values of its deepest leaves? Okay, I think this should be an easy problem. Given the root binary tree, return the sum of the values of its deepest nodes. Okay. Right, so we're gonna have to do BFS here. Level order traversal. Because you've got to look for the values that let's do breadth first search here. So from collections, import DQ. We start off with our create a queue, DQ, we pass in our root. While queue, we want to start at the get the length, right? So the length is the length of queue. Length is length of queue. And we want to loop, do a for loop here. We'll loop for I in range length. For I in range length. In range length. In range length Q. do the queue. Just take it out. So we do well. Node is equal to q dot top left. And we want to check if it's the deepest node. Right, so we do well. We need to check if node dot left or node dot right. We create a sum up here. Just do like a res is equal to 0. We check if node dot left or node dot right. Sorry, if not node dot left, or if not node dot right. Then we want to append sum plus or equal to node dot val. And this cat, man. Sorry, this is res. Plus equal to node dot val. Check left, check right, check left. Then if it's not, check left and right. Then we do, well, if not, node dot left. If node dot left, then we append q dot append node dot left. And we do if node dot right, q dot append node dot right. And we want to return our if we get to this, we return our res. That's the next for iron range length Q. Use it. If not node, then we just return node.val. There's no left. Oh, and not. It's not rude. Why are we not adding anything, dude? Why are we not appending it? Why is this not appending, bro? I don't understand. Like, Oh my god, the return statement, bro. Are you outside the wild, dude? Okay, finally, we're returning something. Okay. 2015, 2019. Let's print no doorbell. Let's see what we're... Oh, the deepest leaves. Okay. Okay, so you don't want to include 5 here, so we're just appending all the leaves, right? But here, let's check 2. We got 1. Okay, I think we just want to append the deepest level of leaves, so how can we change that up? We can do, well... we needed to somehow have some sort of flag, I think, in order to check, well, what the level is. Node 0. It's not level. For that level, we got q.pop left. I'm thinking maybe just putting in like a flag in here. That's so smart, bro. That's so smart. We reset res at every level. I didn't think about that. That is a really smart way to do it. So you put node here, put, get rid of this root, keep it at that, and we just reset res at each level. Because really the only level we want to return is the level with all the leaves. Which I think this should run. Like... here. There we go. Ah, interesting. It's my anxiety. It's my anxiety. What did they do here? Same thing as me. DQ root. what did I do? While q res is equal to 0 for I in range length q. B is equal to b dot pop left res. This is literally my same solution. Solution BFS. Here's the BFS. Traverse tree, find the max traverse tree again to complete the sum required. Okay, alright. Appreciate you guys watching. A little bit of a shorter video. You know, I'm probably just going to work on some more problems back when I'm in Chicago when my girlfriend's working. But yeah, appreciate you guys watching. I'll see you Monday.